Welcome to another section in further maths. Today we'll be talking about symmetric properties of roots. Now, in our last section we said something about having a quadratic equation of this form: ax squared plus bx plus c equals 0. But before we continue with this, I would like us to take preview of what we did in our last lesson. Welcome back. Now let's continue from here. We have ax squared plus bx plus c equals 0, and we concluded that when you talk about the roots of the equation, there's a general solution that goes this way: alpha plus beta is equal to minus b all over a, and alpha beta is equals c all over a. This is for sum of roots, and this is of product of roots. Now, certain relations involving alpha and beta can also be determined from alpha plus beta and alpha beta, that is from the sum of roots and product of root of equation, even when we do not know alpha and beta distinctively. Such relations are usually said to be symmetric. They are symmetric in the sense that if alpha and beta are interchanged, either the relations remains the same or is multiplied by -1. Now, what is trying to tell us now when you talk about symmetric is a kind of trying to check the commutativity of a particular relationship. For example, if I said a plus b, if it is the same thing as b plus alpha, then they are symmetric. This is symmetric because even if you interchange them, your value is still the same. Now, if you want to prove this, if we have, let's say a is 2 plus 4, our answer is 6. Now remember, b is 4, a is 4. Now if you put this to be 4 plus 2, your answer is still 6. So since these two values assume the same number even when being interchanged, when talking about the symmetric properties of roots, we say these two values are symmetric. Now let's try something. If alpha is not equals beta, determine the symmetric confidentiality of the listed expression. Now we'll want to check if number 1, alpha plus beta is equals beta plus alpha. Now, from the instruction, like what we proved in our previous lesson, if alpha is 2 and beta is 4, so 2 plus 4 is 6, and here 4 plus 2 is still 6. So alpha plus beta being equal to beta plus alpha is symmetric. Is symmetric. That's number 1. Let's check if alpha square beta square is symmetric. Now let's try. Is it the same thing as beta square alpha square? Remember what we've been using, 2 and 4. Let's try it. Our alpha here is 2, so putting 2 here, we have 2 square times 4 square. Is it the same thing as 4 square times 2 square? So 2 square here is 4 times 4 square is 16. Now 16 times this is 64. Now let's see if this other part will also give us the same thing. 4 square here is 16 times 2 square, 4, which is the same thing as 64. So alpha square beta square is the same thing as beta square alpha square. So is symmetric. Now let's try another one. We've done for alpha square beta square. Let's try for alpha beta. Is it the same thing as beta alpha? Okay, this is 2 times 4, which is 8, and this is 4 times 2, which is 8. So alpha beta is symmetric to beta alpha. Now, okay, is symmetric. Now what if we have something like 3 alpha? We have 3 alpha plus 2 beta. Is it the same thing as 3 beta plus 2 alpha? Let's confirm. Our alpha here is 2. 3 times 2 is 6, plus our beta is 4. 2 times 4, 8. 6 plus 4 is 14. Let's see if we have the same answer here. 3 times 4 is what? 3 times 4 is 12, plus 2 times 2. Okay, our A is 2 and our B is 4. So if we do 3 times 2 is 6, plus 2 times 4, which is 8. 8 plus is 14. Now 3 times this is 12, plus 2 times 2 is 4. So 4 plus this is 16. So you can now see that this is not equivalent to this. So therefore 3 alpha plus 2 beta is not symmetric. It's not symmetric. That's how to check the symmetric property of certain equations. I hope this lesson is a very wonderful one. So to refresh your memory on what we've just discussed, take the test on the screen. Now do well to also use the lesson notes on the platform for better information on the topic we've discussed. Feel free to drop your questions on the comment section. I'll see you in our next class.